हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइस डू लेट मी नो if my audio and visual quality are clear or not. This is Chandrashekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. I hope everyone is safe and sound. And today, as you can see, we are going to start the discussion about the radiation basics, the basic definitions which are going to help you to in understanding the radiation. But before that, before we start our session, please do let me know if I'm audible and visible to everyone, so that we can start our session. Did you guys revise the concept of radiation before coming to the class? I had asked you guys to have a quick revision, because if you will have a little bit understanding, you will be able to involve yourself in the discussion and you will improve your understanding by being part of this session. Please do let me know if I am audible and visible to everyone. Please respond. Those who are watching me live, and those guys who are meeting me for the first time, this is my quick introduction. I am Chandrashekhar, mechanical engineering graduate from IIT Delhi and also an engineering services examination qualified. I have worked in SAIL for a couple of years and I have also worked in private consulting firm for more than 2 years. And I am having more than 9 years of teaching experience in GATE, IES and other PSUs. Please respond through the comment section, because without your involvement, the session could not be complete. So it is my humble request to every one of you who are part of this session to just respond if everything is all fine. My video, my audio, and you can always contact me on the mail ID which is there on the screen. You can join me on the Telegram, that is Mechanical by Chandrashekhar, and this is the link for my Telegram group. Once you become part of my Telegram group, you will be getting all the updates, notifications of all my free classes, plus you will be getting the PDF of these sessions also. And you can have one-to-one doubt clearance also by being part of this Telegram group. Join me on the Telegram if you have not joined it yet. Other than the free sessions, we are providing you the paid courses. BYJU'S is providing the students the paid classes also, where we complete the entire syllabus of GATE in detail along with the study notes, and there will be workbooks also provided to you all. So you can join us through the paid courses as well. So before finally we start, please keep your pen, paper and calculator handy, so that you can write the important points in your notebook so that you will not forget them, and you can always raise your concern, raise your doubts through the comment section which is there, which is available to you. You can talk to me through the comment section. But I have not received any comment yet. Can you guys hear me? Am I audible and visible to everyone? Knock knock. Or I am not able to see your comments, or you are not writing anything. Shall we start? What is the day today? So the topics which we are going to cover in today's session, as I told you yesterday, the series is all about completing the thermal radiation in detail. Right? I cannot see your comments. Can you guys hear me? So we will talk about the thermal radiation, basic of thermal radiation, importance of thermal radiation. Then we will be talking about the emissive power, significance of emissive power. And after that, we will be talking about the various radiation properties like reflectivity, absorptivity, transmissivity, emissivity, etc. Then we will be talking about the concept of the black body. Hi Kameshwar, good evening. Welcome to the session. I want everyone to respond through the comment section. Are you guys all ready to explore the beauty of radiation analysis or the important topic of heat transfer, that is thermal radiation? So there is a question on the screen. I hope you have revised the concept, basic understanding. You already have. So that is why there is a question appearing on your screen. Just select your answer as per your understanding. The absorptivity of a material, absorptivity is one of the radiation property. The absorptivity of a material depends on its temperature. Is it yes or no? Everyone, please do respond. And then based on your response, we will continue our session. What do you think about the absorptivity, which is denoted by alpha? That is the absorptivity of a material. Kameswar is only talking to me. What about others? Where are others? Absorptivity depends on its temperature. Is the statement true or false? How many of you agree with Kameshwar? Okay, so let us start our session. I will disclose the answer at the end of this session. So please keep your pen, notebook. Ankit is saying no. Then on what it depends? So shall we start? Please make some noise. Where is the Josh? Keep your pen, notebook and calculator so that we can start our session. And whenever you are having any doubt, you can raise your doubts through the comment section. I have received only two answers. Yes from Kameshwar, no from Ankit. How many of you agree with Kameshwar? How many of you agree with Ankit? Good evening, Bhavya. Welcome. There was the question on the screen. Absorptivity of a material depends on its temperature. Whether the statement is correct or not. Please respond, guys. Okay, so let us start talking about the radiation. Yesterday, if you are part of my yesterday's session, yesterday I had talked about the radiation, as radiation occurs in the form of electromagnetic waves due to change in electronic configuration of molecules, atoms and subatomic particles. That is how radiation is developed, electromagnetic waves as per the Maxwell's theory. Now, though all the electromagnetic waves are having same general features, but the electromagnetic waves at different wavelength show some different behavior, and that is why the electromagnetic waves are characterized by their wavelength range, right? So the classification of these electromagnetic waves is based on the wavelength range, and the electromagnetic waves which are having lowest value of wavelength are most dangerous. So the radiation can be classified as cosmic rays. They can be gamma rays. They can be X-rays, ultraviolet, based on the wavelength range, and ultraviolet. Then visible light. Then infrared. And then microwaves. Have you used microwave oven? Are you guys using microwave oven at your home? Then radio waves. Depending on the wavelength range, the wavelength increases in downward direction. The wavelength is increasing in downward direction. So the most dangerous are cosmic rays, gamma rays, X-rays, etc. Because those electromagnetic waves are dangerous, which are having low value of wavelength. So the lowest value of wavelength are cosmic rays, X-rays and gamma rays. Nuclear engineers study about these radiations. Nuclear engineer are studying about these. And microwaves and radio waves are studied by electrical engineers. And we as mechanical engineers, we are going to discuss these radiation, ultraviolet, visible and infrared. They are part of thermal radiation. Mechanical engineers study about these radiation. They constitute thermal radiation, right? So the microwaves which are generated in microwave oven, they are actually, as I told you, the different electromagnetic waves show some specific properties at a particular wavelength. The microwaves, if we talk about the microwaves, they are reflected by metals. The microwaves are having the property that they are reflected by metals. They are transmitted by plastics and glass, and they are absorbed by food or water molecules. And because of these properties, they are used in cooking. Microwaves are used in cooking, right? Now, what is thermal radiation? If we talk about the thermal radiation, our discussion is all about the thermal radiation. The thermal radiation are the appearance of electromagnetic waves in the form of heat. The appearance of electromagnetic waves in the form of heat. They are called as thermal radiation, or we can say they are related to temperature of a surface. The thermal radiation are related to temperature of a surface, right? And the wavelength range for thermal radiation is 0.1 micrometer to 100 micrometers. So this range covers part of ultraviolet radiation, plus visible light, plus infrared. If we talk about the range for ultraviolet radiation, the range for ultraviolet radiation is from 10 to the power -2 micron to 0.38 micron. And for visible light, it is 0.38 micron to 0.78 micron. And for infrared, it is 0.78 to 10 to the power 2 micron. These are the wavelength range for these electromagnetic waves. So that is why from 0.1 micron, 10 to the power -1 micron to 10 to the power 2 micron, it covers the part of ultraviolet, visible and infrared radiation. So each and every substance, every surface emit the thermal radiation when the temperature of the surface is greater than absolute zero. When the temperature of the surface is greater than absolute zero, so temperature greater than 0 Kelvin, there are thermal radiation emitted by the surface. And as the temperature increases, the radiation emitted will have low wavelength. As the temperature increases, the wavelength gets decreased. If we talk about the solar radiation, can you just let me know what is the wavelength range for solar radiation? For solar radiation, what is the wavelength range? Anybody having any idea? Please do let me know. For solar radiation, what is the wavelength range? It is 0.3 micron to 3 micron. It is around 0.3 micron to 3 micron. The solar radiation, which is at higher temperature, sun is at very, very high temperature, around 3000 Kelvin. So the solar radiation, the wavelength range for solar radiation is 0.3 micron to 3 micron, which covers some ultraviolet radiation also, visible light also, infrared also. A body at room temperature, what is the wavelength range for body at room temperature? A body at room temperature emit infrared. A body at room temperature emit infrared radiation. And if the temperature, the body at temperature greater than 800 Kelvin, body at temperature greater than 800 Kelvin start emitting visible light. If the temperature is very high, they start emitting the visible light. So at high temperature, the wavelength range emitted by the surface is less, and at low temperature it is large. The wavelength is very large, and that is why the radiation which are having low wavelength are most dangerous, like X-rays, gamma rays. They are very dangerous to the human body. All right. Now, if I was talking about the radiation emitted by the surface, every surface emits the radiation when the temperature of the surface is greater than absolute zero. The temperature is greater than 0 Kelvin. So, based on the emission from a surface, there is a parameter defined that is called as emissive power of a surface, denoted by E. What is emissive power? The amount of radiation emitted by a surface per unit time, that is joule per second per unit area, in all the direction over the entire wavelength range. So it will be joule per second per unit area, meter square. So joule per second is watt, the unit will be watt per meter square. Emissive power of a surface depends on its temperature. Emissive power of the surface depends on the color. Emissive power depends on the roughness of the surface. So emissive power of a surface depends on the temperature of the surface, depends on the surface condition like color and roughness, and it also depends on the material of the surface. And for any surface which is at temperature T, we can define or we can find out the emissive power comparing with the black body. This is how the emissive power of a surface can be written. This is the emissive power. The unit is watt per meter square. Epsilon is called as emissivity of a surface. Epsilon is emissivity. Do you know what is emissivity range? What is the range of emissivity of a surface? Epsilon is the emissivity of the surface. Any idea? What is the range for emissivity of a surface? Emissivity lies between 0 and 1. Does emissivity depends on temperature of the surface? Does emissivity depends on the temperature of the surface? Can anyone let me know? So this is all about the emissive power. According to Stephen Boltzmann law, how do we define the emissive power of a surface? Comparing with the black body. So emissivity multiplied by emissive power of the black body is the total emissive power of a surface. So emissivity is 1 for a black surface, emissivity is 0 for a white surface, and other surfaces are having emissivity between the emissivity between 0 and 1. According to Stephen Boltzmann law, have you studied the Stephen Boltzmann law? Very important law in defining the radiation. According to Stephen Boltzmann law, for a black surface or a black body which is at a temperature T, the emission from the black body or the emissive power of the black body is given by, this is EB. The emissive power of the black body is given by sigma into T to the power 4. The unit is watt per meter square. That is the emissive power of the black body. And sigma is equal to, where sigma is where sigma is given by 5.67 into 10 to the power minus 8. What is the unit of sigma? What is the unit of sigma? That is the Stefan-Boltzmann constant. Sigma is the Stefan-Boltzmann constant. What is the unit of sigma? So we can say emissive power of a black body is directly proportional to emissive power of a black body is directly proportional to T to the power 4, and T is the absolute temperature of the black body. T is the absolute temperature of black body. What is the absolute temperature? That must be in Kelvin. That is important. The temperature has to be in Kelvin. So the radiation, the total radiation emitted by the black body will be equal to EB multiplied by area, or we can say sigma into T to the power 4 multiplied by area. That is the unit will be watt or joule per second. That is the radiation emitted by the black body. And for the real body, for a real body, it will be the emissive power of a real surface will be equal to epsilon into EB, that is equal to epsilon multiplied by sigma into T to the power 4. Yes, the unit is watt per meter square Kelvin to the power 4. That is the unit of sigma. That is called as Stefan-Boltzmann constant. Is this clear? The unit is watt per meter square. And if we multiply with area of the surface, we will be getting the total radiation emitted by the real surface per unit time. The radiation emitted by the surface per unit time. If anybody is having any doubt, anything to ask, please do let me know. Otherwise, there is a question on the screen. Do let me know the answer to this question. Then we will proceed further. इसका आंसर बताइए. You guys are not responding. I keep on asking you so many things. What is the answer to this question? I had asked you, emissivity depends on temperature or not. Nobody had given me the answer. I asked you, absorptivity depends on its temperature or not. Only few students gave me the answer. The emissive power of a black body is P. If its absolute temperature is doubled, then emissive power becomes. So EB is directly proportional to T to the power 4. So from here, what will be the answer? If we make the temperature twice, then it will become 2 to the power 4. D is the correct answer. Yes, Kameshwar. Good, good. Good, Bhavya. Well done. Keep it up. Now, I had mentioned that all the surfaces emit the radiation, and from that we can find out the emissive power of the surface. If it is a black body, epsilon will be 1 and emissive power will be sigma into T to the power 4. And if it is a real surface, then we have to multiply with emissivity of that particular surface. Now let us talk about the irradiation or insolation. Anybody is having any idea about insolation? The radiation, the surfaces emit the radiation as well as they receive the radiation emitted by other surfaces as well as reflected by the other surfaces. So the amount of radiation incident on a particular surface, that is called as insolation or irradiation. It is incident radiation. We can call it as incident radiation. The radiation incident on a surface per unit time, per unit area from all the direction over the entire wavelength range, that is called as irradiation or insolation, denoted by G. The unit is again watt per meter square. Now, it is very, very important for you to understand that the irradiation or insolation does not depend on the surface. It depends on the surface condition of the source from where the radiation is emitted or the radiation is coming. It does not depend on the, if we want to find out the insolation for this is our surface. If we want to find out the insolation, so insolation depends on the temperature. This is the source. Insolation depends on the temperature, surface condition, color, roughness and material of source. It is not a function of this surface. It is not function of parameter of the surface. Rather, it is the function of the parameter of the source from which the radiation is incident. Similarly, emission talks about the emissive power, talks about the emissivity. So emission depends on the temperature, color and the roughness of the source, the surface from which the radiation is emitted. So that is why the emissivity depends on the temperature, color and roughness of the surface from which the radiation is getting emitted. Whereas absorptivity for a surface, for a particular surface, the absorptivity depends on the temperature of the source from where the radiation is coming. If we want to find out the absorptivity for the surface 1, then it will not depend on the temperature. Absorptivity for the surface 1 is not a function of temperature T1. Rather, it will depend on the temperature of the source. Alpha 1 will be a function of T2. So the answer to this question, which I had asked you earlier, Kameshwar, have you understood it? The absorptivity of a particular surface does not depend on the temperature of that particular surface. Rather, it depends on the temperature of the source from where the radiation is incidenting on that particular surface. So the answer, Ankit had given the correct answer. The answer to that particular question was definitely no. Now, the radiation is emitted by a surface. The radiation is reflected by the surface. So that is the total radiation which leaves the surface, and the total radiation which is leaving a particular surface is denoted as radiosity, denoted by J. What is radiosity? The total radiation which involves the emitted radiation plus the reflected radiation. The total radiation which leaves a particular surface per unit time, per unit area, in all the direction over the entire wavelength range is nothing but the radiosity of a particular surface. So we have talked about three parameters or the three definitions related to radiation, and all are having the same unit, that is watt per meter square. They are actually the flux per unit area. They are called as radiation flux. One is the emissive power of a particular surface, can be calculated from Stephen Boltzmann law. Then it is the incident radiation or insolation, can be calculated from the emission of the source. And the third one is the radiosity. Which one, Kameshwar? The emissive power is the radiation emitted by a surface. The insolation is the radiation incident on a surface, because any surface emits the radiation as well as the surface receives the radiation. So the amount of radiation emitted by the surface is emissive power. The amount of radiation received or the amount of radiation incident on a surface is called as insolation or irradiation. And the surface also reflects the radiation. For an example, if the radiation incident on a surface, part of that radiation is absorbed by the surface, part of that radiation is transmitted by the surface, and there is a portion which is reflected by the surface. So the total radiation which is leaving from a particular surface, which involves the emitted radiation as well as the reflected radiation, combined together becomes the radiosity of a particular surface. All the three terms, emissive power, insolation and radiosity, the unit of each and every term is watt per meter square, but they are having different significance. Is this clear? So if we try to combine these three parameters together, if we try to combine these for a particular surface, look, this will explain everything. This figure, this analysis will explain everything. So there is a surface that is under observation. This is the surface under observation, let us say. Now the surface is emitting radiation. The surface is emitting radiation. If it is a non-black surface, if the surface is non-black, so the radiation emitted by the surface is epsilon into EB. The radiation emitted by this surface is epsilon into EB. That is one thing. That is a separate thing. That is called as emissive power. We can call it as emissive power. This is E, emissive power. Now, from some source, there is some radiation which is incident on the surface. That represents the incident radiation, or we can call it as insolation for the surface. That is insolation for the surface G, or we can call it as irradiation. Now, out of this irradiation, some fraction is reflected by the surface. That is called as reflected radiation, and combined together, reflected, this is the total radiation which is leaving the surface. This is the total amount of radiation which is leaving the surface, which is reflected as well as emitted. We can call it as G rho. That is called as reflected radiation. Out of the incident radiation, some portion will be reflected by the surface. So reflected and emitted radiation taken together constitutes the radiosity of the surface. Is this clear now, Kameshwar? Or we can understand this concept by considering your bank account. This is your bank account, let us say. Now you must be having some income. The income is G. You must be working somewhere, and you are getting income credited in your account. That is your income. And you must be having some basic expense. You must be having some basic expenses. Whether you are working or not, you must be having some basic expense to have your living. For having the living, you need to have some basic expense. Bread and butter, that is the basic expense, that is emitted radiation. But you must be having, if you are working somewhere, if you are earning money, then you must be having some luxury expense also. That depends on your salary. Your luxury expense. There are two types of expenses people do. One is the basic expense. We cannot avoid that. To have the living, we need to spend some amount for the basic things, or the necessary things. That is called as basic expense. That is the emission from the surface. And other than that, if you are working somewhere, if you are earning money, then you must be having some dreams. To have the iPhone, to have the bigger car, to purchase a flat. That is the luxury expense. That depends on your salary. More is your salary, more will be your luxury expense. So we can say this will be the total expense. This is the total expense. This is the total expense, and this is your income. Now we can say your total expense is nothing but your basic expense plus your luxury expense, isn't it? The total expense, that is the radiosity, is sum of your basic expense plus the luxury expense, that is the reflected radiation. That is the relation between these three parameters. And we can say from here, we can say J is always greater than equal to E. The minimum value of J can be E. The total expense can be equal to your basic expense. It cannot be 0. J cannot be 0. The value of J can never be 0. J can minimum be equal to, J minimum is equal to E. When the reflectivity is 0 or the surface is non-reflector. If a person is not spending extra than his basic expense, then his total expense will be equal to the basic expense. The minimum value of J is equal to E, isn't it? For non-reflector surfaces where the reflectivity is 0, J minimum is E. And what is the maximum value of J? When when the person is spending all his income to the luxury items. Basic expense has nothing to do with the income, but maximum value of J is equal to E plus G, isn't it? When rho is equal to 1, or it is the when the surface is a perfect reflector. So the minimum value of radiosity is equal to basic expense or the emitted radiation, and the maximum value of J will be E plus G. Is this clear to everyone? Now again, let us have understanding. This is your income, this is your total expense, J is the total expense, that is the total expense, and what we can say, J can be greater than equal to less than G. The value of J can be greater than equal to or less than G, isn't it? If J is greater than G, it means the total expense is more than the income. Then what will happen? If the expense is more than income, then there is a decrease in the amount in your account. If J is equal to if J is greater than G, if the radiosity is greater than G, then it is the net heat loss from the surface. It is the net heat loss from the surface, and Q by A is equal to, that is the net heat loss from the surface, is equal to J minus G. The unit is watt per meter square. If there is a possibility, if J is equal to G, there is a possibility that J is equal to G. It means expense is equal to income. So we can say there is no heat loss or no heat gain. There is neither any heat loss from the surface nor any heat gain. So Q is equal to 0. In that case, Q will be equal to 0. The third situation is if J is less than G, there is a possibility that the radiosity can be less than G. Then we can say it is net heat gain by the surface. What is the net heat gain? Q by A gain is equal to G minus J. Unit is watt per meter square. Unit is watt per meter square. That is all about these three important parameters which are helpful in understanding the radiation. Let us talk about the various properties of radiation now. Radiation properties. The radiation properties are absorptivity, reflectivity, and transmissivity. Absorptivity, reflectivity, and transmissivity. This is the incident radiation, let us say G. Out of the incident radiation, some fraction will be reflected by the surface, some fraction will be absorbed by the surface, and the remaining fraction will be transmitted by the surface, isn't it? If there is a radiation incident on a surface, then out of that irradiation, some part will be reflected by the surface, some part will be absorbed by the surface, and some part will be transmitted by the surface. So absorptivity of the surface is defined as the fraction of irradiation, that is the incident radiation, absorbed by the particular surface. That is G alpha. Absorbed radiation is G alpha. So the absorptivity is the ratio of the fraction of irradiation. So absorptivity can be defined as G alpha divided by G. That is called as absorptivity of a particular surface. Similarly, the fraction reflected by the surface is called is defined its reflectivity, G rho. So what is the reflectivity of the surface? The fraction of irradiation reflected by the particular surface is called its reflectivity. So we can say the ratio of G rho by G is called as reflectivity of the surface. And the some radiation is transmitted by the surface. The transmissivity is defined as the fraction of irradiation transmitted by the surface, or we can say G dot divided by G. That is called as transmissivity of the surface. These are called as radiation properties, and all the radiation properties R positive fraction, the value of these radiation properties lies between 0 and 1. They are positive fraction. The value of these radiation properties lies between 0 and 1. Is this clear? Is it all clear? If we apply the energy conservation, look, the incident radiation is, let us say, let me call the incident radiation to be G is equal to 100 unit. Out of this 100, the reflected part of radiation is, let us say, 50. 50 is reflected by the surface, and let us say 30 is absorbed by the surface. The remaining 20 will be transmitted by the surface. Whatever the total radiation incident on a surface should be equal to the sum of reflected, absorbed and transmitted radiation, isn't it? So if we apply the energy conservation for the particular surface, then we can say the total incident radiation is equal to absorbed radiation plus reflected radiation plus transmitted radiation. That is, the unit is watt per meter square. The total radiation incident on a surface will be sum of reflected, absorbed as well as transmitted. And if we divide by G, if we divide this equation by G, so the left hand side will be 1 is equal to G alpha by G plus G rho by G plus G tau by G. This is the expression. And what is G alpha by G? That is alpha, absorptivity. What is G rho by G? That is called as reflectivity. And G tau by G, that is called as transmissivity of the surface. So we can say for any surface emitting any type of radiation, for any surface emitting any type of radiation, the sum of these radiation properties, which is alpha plus rho plus tau, is always equal to 1. The sum of alpha plus rho plus tau will always be equal to 1. Bataiye, anybody is having anything to ask, please do let me know. There is a question on the screen. Can you just let me know the answer to this question? Quickly, let me know the answer for the question which is there on the screen. What is opaque surface? When transmissivity is equal to 0, that is called as opaque. And when transmissivity is equal to 1, that is called as perfect transmitter. Perfect transmitter. Similarly, when alpha is equal to 0, is called as non-absorber. When alpha is equal to 1, it is called as perfect absorber. And when rho is equal to 0, it is called as non-reflector. And when rho is equal to 1, it is called as perfect reflector. The value of alpha, rho and tau lies between 0 and 1. Minimum value can be 0, maximum can be 1. Perfect reflector. So what is the answer? As we all know, alpha plus rho plus tau is equal to 1. But because it is about opaque surface, that is equal to tau is equal to 0. So alpha plus rho is equal to 1. Option C is the correct answer. Option C is the right answer. Yes. Yes, Sairam. Bhavya. Well done. Kameshwar. Good, good. Can you quickly solve the next one? Can you solve the next question? Solar radiation of 1200 watt per meter square falls on a gray opaque surface. Tau is equal to 0. So we can say alpha plus rho is equal to 1. Of emissivity 0.5. If the surface temperature is 50 degrees Celsius and the surface emissive power is 600 watt per meter square. Emissive power is 600 watt per meter square. The radiosity of that surface is, what is the radiosity? That is E plus rho G. This is incident radiation, that is G. Solar radiation of 1200 watt per meter square falls on a gray opaque surface. So the incident radiation is 1200. Emissive power is 600, that is E. We need to find out rho. What is the value of rho? What is the value of rho? Do you know the Kirchhoff's law of radiation? Anybody is having any idea about Kirchhoff's law of radiation? According to Kirchhoff's law, the absorptivity of a surface is equal to its emissivity when the surface is in thermal equilibrium with its surrounding. For a surface, the absorptivity is equal to emissivity when the surface in thermal equilibrium with its surrounding, or we can say a good absorber is also a good emitter. That is what is Kirchhoff's law. So emissivity is given. Can we say alpha is equal to emissivity is equal to 0.5? And if alpha is equal to 0.5, rho can be calculated. That is 1 minus alpha. And that is also 0.5. So the radiosity of the surface is 600 plus 0.5 into 1200 will give you the answer. So what is the correct answer? It is also option C, which is correct. It is also option C, which is. Now the next part is the black body. As I told you that to find out, to define the emissive power of a surface, we need to compare it with the emissive power of the black body. But what exactly is the black body? Black body is a hypothetical concept. Black body is hypothetical. It does not exist in reality. So black body is a special type of surface which emits the maximum possible amount of radiation at any particular temperature. The radiation emitted by the black body is maximum corresponding to the particular temperature, and which is given by the radiation emitted by the black body is given by sigma into T to the power 4. That is called as black body. Or we can say for a black body, the black body is a perfect absorber of all type of radiation. Absorptivity is equal to 1. For the black body, absorptivity is equal to 1. Also, the black body is opaque to all type of radiation. Transmissivity will be 0. And because it is a perfect absorber according to Kirchhoff's law, the black body is also a perfect emitter of all type of radiation. Epsilon will also be equal to 1. So why do we, if it is a hypothetical concept, then why do we define the black body? Because it simplifies our analysis of radiation. It gives us the reference to compare the radiation for all the real surfaces. And most of the radiation laws are based on this black body concept only. That is how we define the black body, which is hypothetical, and the radiation emitted by the black body is maximum. That is why it is taken as the reference for comparing the radiation for all the other surfaces. And lastly, let us have a quick look about the emissivity of the surface. What is emissivity? Emissivity is also called as color factor of the surface. It is also sometimes denoted as color factor of the surface, denoted by epsilon. So it accounts for color and nature of the surface. Surface condition. Nature means surface condition. It depends on color and the surface condition of the surface. What exactly is that? It is the ratio of emissive power of a surface to the emissive power of a black surface at the same temperature. So we can say it is epsilon into sigma into T to the power 4. Or we can say epsilon is given by emissive power for the radial surface divided by emissive power for the black. It also depends on the temperature of the surface. Unlike absorptivity, absorptivity depends on the temperature of the source rather than the temperature of the surface. Whereas the emissivity depends on the temperature of the surface for which we are defining the emissivity. Emissivity is both spectral and directional. It depends on lambda also, it depends on the direction as well. And because it depends on wavelength, we define another term or another property. This is also the radiation property which lies between 0 to 1. It is also a radiation property For a white body, emissivity is 0. For a black body, perfectly black body, emissivity is equal to 1. So monochromatic emissivity is the emissivity at a particular wavelength. It is defined as emissivity at a particular wavelength. I hope this is clear to everyone. Now, if I show you the spectral variation of emissivity or epsilon as a function of lambda, so based on the spectral variation, we can define the surface to be black body if the emissivity is equal to 1. Or we can say epsilon lambda 1 is equal to epsilon lambda. Monochromatic emissivity at any wavelength is always equal to 1. That is called as perfectly black body. When the emissivity this is the white body when emissivity is equal to 0, or that is equal to epsilon lambda 1 is equal to epsilon lambda 2 is monochromatic emissivity is also equal to 0. For a real surface, emissivity is a function of lambda. It is different at different wavelength. So to keep our analysis simple, because emissivity depends on wavelength also, to keep our analysis simple, we define a gray surface. What is a gray surface? Gray surface is again a hypothetical surface which is a compromise between black body and real surface, where the emissivity is not a function of wavelength, but it is not equal to 1. It is neither equal to 1 nor 0, but definitely its emissivity is independent of its wavelength, or we can say epsilon lambda 1 is equal to epsilon lambda 2 is equal to constant that is denoted by epsilon average. That is called as gray surface. So we define the gray surface to make our radiation analysis simple. Otherwise, analyzing the radiation for a real surface is too complicated, too difficult, because all the radiation properties depend on the wavelength as well as the temperature of the surface. I hope it is clear. Hi Rajendra, good evening, welcome. Anybody is having any doubt, please do let me know up to this point. So that is all from my side for this session. There is an assignment question which is there on the screen. Try to solve this assignment question at home and do bring the solution in the next class, or you can share your solution to my Telegram group. If you have not joined my Telegram group yet, I would request everyone to be part of my Telegram group, that is Mechanical by Chandrashekhar, and we will be meeting tomorrow at 7 p.m. and we will talk about very important, beautiful and interesting topic of radiation, that is radiation shape factor. So I would ask you, I would request you to have a quick revision or quick study about the radiation shape factor. All right. So with this motivational saying, a big journey always begin with small steps. If you are working hard and if you are not getting the desired result, don't lose hope, because if you are dreaming big, then your journey will be in the right direction with the small steps. That is all from my side. See you tomorrow. This is my email ID. You can always be part of my Telegram group also, which is there on the screen. So again, I would request everyone to do like, share and subscribe our BYJU'S YouTube channel. All right. So that is all from my side. Thank you guys. Thank you for being part of this session. See you tomorrow sharp at 7 on the same platform, and do not miss tomorrow's session, because it is going to be very important to understand the radiation shape factor. Thank you guys. Good night. Stay safe, stay healthy and keep preparing with your full dedication and hard work. Thanks a lot. Jai Hind.